So in last video, we have seen the introduction to multithreading. What is multitasking? What are the two types of multitasking? Process-based multitasking and thread-based multitasking, correct? Now in thread-based multitasking, we will learn about thread-based multitasking in this. Now what we will see how to define a thread. We have already seen what is a thread. Now we will see how to define a thread, okay? So let's begin this video now. So how to define a thread? This is a very important question. It can be asked in an interview room. So we can define a thread in two ways. First is by extending thread class, and the second is by implementing runnable interface. So first is by extending thread class, and second is by implementing runnable interface. So we will see in very detail what is thread class. So we will see so many functions of thread class in this video lectures of multithreading, correct? So what type of methods are there in thread class? So each method that is used in multithreading is mostly present in thread class, okay? This class is created for multithreading. And what is the runnable interface? So the runnable interface should be implemented by any class whose instances are intended to be executed by a thread, okay? So runnable interface is also actually used mostly by a thread, by the classes which use a thread, okay? So the runnable interface should be implemented by any class whose instances are intended to be executed by a thread. Whose instances are intended to be executed by a thread, that class should implement runnable interface, okay? The class must define a method of no argument called run. Now what is the meaning of this? Since it is an interface, so it does not contain method definition, it only contains method declaration, okay? So it contains a method of known as run. It contains a method known as run. Only a single method. Runnable interface only contains a single method known as run, okay? So any class who is implementing runnable interface has to define this method, has to write the code inside of it, okay? Any class who is implementing runnable interface. So how do we define a thread? By extending a thread class or by implementing runnable interface. We will see both these ways now, okay? First we will start with by extending thread class. Fine. So let's begin how you will define a thread by extending a thread class. But remember this question, we can define a thread in two ways, okay? This is an important interview question, by extending thread class and by implementing runnable interface. Fine. So define a thread by extending a thread class, okay? So now I will show you some code. So class child thread extends thread. So what we are doing, we are creating a class known as child thread. What we are doing, we are creating a class known as child thread, and it is extending a class known as thread, and it is extending a class known as thread. So this is nothing but inheritance. This is nothing but inheritance. All the functions of threads now are accessible by the object of child thread as well, okay? So class child thread extends thread. Next, what we have to do is we have to override a run method. We have to override the run method. So thread class, inside of it contains a method known as run, okay? Inside of it contains a method known as run. Runnable interface actually contains the method known as run, but it is an interface. It does not implement it. But what thread class does, it implements, and there is not a single line of code inside of it. There is not a single line of code inside of it. Why is this so? Because thread class itself implements the runnable interface. Thread class itself implements the runnable interface. And since runnable interface is an interface and it contains a run method, the thread class has to declare this method. I think you know the rules of interface in class, okay? So since it is an interface, so it has to, thread class has to declare or implement this method run. So it does implement it, but without a single line of code. It does implement it so that no error will occur, but without a single line of code. So any child thread that extends a thread, any class that extends a thread and want to use the run method, it has to implement that run method on its own, okay? It has to override the run method. So what we will do now, we will write the code of run method on our own, whatever we need, okay? So public void run, and this is the code of the run method that we need, okay? I want to print 5 times child thread. So this will override the run method of thread class. This will override the run method of thread class. Now what I will do, I will create a class test. This will contain my main method, and in this main method I will declare the object, I will initialize the object of child thread. So this is the initialization of object of child thread name ct. The reference variable is ct, and this is the initialization of object. I think most of you know it. Now ct.start, it is a method. Start is a method of thread class, okay? It will start. Then the main method will contain system.out.println the main thread, okay? So this is our whole code. This is the whole code. Now let me explain each step by step what is the meaning of each line in this code, okay? So from this line to this line, it is known as defining a thread. This is how we define a thread. Define a thread. Okay, this is known as defining a thread. Next, this is known as a job of a thread. So this is the job of my child thread. This is known as a job of a thread. Okay, what is the next point then? Now each Java program has by default one thread. Each Java program by default has one thread. And what is that thread? By default, each Java program contains main thread. So this is also an important question. You can note it down. So by default, each Java program has a main thread and it is created by JVM. It is created by JVM. So this main thread begins its execution from the main method. Okay, whenever we have a main method, so the main thread will begin its execution. Fine. So the main thread is beginning execution from the main method now. Now what will happen? An object is created, ct.childThread ct equals to new child thread. So this is also created by main thread. Okay, because each line executing in this main method is done by main thread. Okay, just a single thread. Now what will happen? ct.start. Whenever a start method is called, a new thread is created. Whenever start method is called, a new thread is created. So a single thread was going on till now, but now a new thread is created. Okay, a new thread is created. So this is the main thread, and this is a new thread, for example T0, that is created. Okay, this thread is nothing but ct, child thread, and this is our main thread. So due to the start method, a new thread will be created. Okay, so now what new thread job is? New thread job is this. The child thread job is this. So it will perform this job, and the main thread job is this. Main job is this, just to print main thread. Okay, so these 5 times child thread and this main thread, now it will be executing simultaneously. Okay, so this is how the thread works. So this ct.start, it is actually starting of a new thread. This is a job of a thread. This is how you define a thread by extending thread class. This is job of a child thread. Okay, so before ct.start, our program just had a single thread known as a main thread. After ct.start, our program has 2 threads, a child thread and a main thread. Child thread job is to execute these lines, and the main thread job is to execute these lines after ct.start. These are important points. Just make a note of them. Okay, now both of the threads will be executing simultaneously. Okay, now the point is, since the jobs are independent, all that matters is they complete as fast as they can. Okay, so the sequence in which they complete does not matter. Okay, the sequence in which they complete does not matter. For example, it can be that main thread will be printed first and then the 5 child threads will be printed, or it can be that child thread will be printed 4 times and then a main thread will be printed and then a child thread will be printed. This is due to the thread scheduler. We will learn about thread scheduler. What it is doing, it is scheduling the threads one by one. Okay, it is giving time for the main thread also, it is giving time to child thread also. Okay, and it seems that both the threads are working simultaneously. Okay, we will learn about this in the future lectures about thread schedulers. Fine. So this is how a thread is defined and extended by extending a thread class, and this is how a main thread is now, and the output is not dependent on us. Okay, the output is dependent on the thread scheduler. We can get a mixed output or a sorted output, but matters is the speed of execution increase. That's what the important point is. The output is not in our hands. It is in the hands of the algorithms used to implement thread scheduler, and it is also operating system dependent. Okay, it can use round robin, it can use priority, it can use FCFS. Okay, these are the algorithms that there are many other algorithms that a thread scheduler can use to schedule these threads. Now since we have 2 threads, so it can use these algorithms to schedule the threads one by one. Okay, so note down these points. A Java program by default has 1 thread, that is main thread. Before ct.start, there was only 1 thread, that is main thread. I have explained you these points. These are just for notes. Now after ct.start, there are 2 threads. What are the 2 threads? There is a main thread and there is a child thread. Okay, now both threads will run simultaneously and the jobs will be completed. Both threads are running simultaneously and the jobs will be completed. Now, but the order of execution is not in our hands. It can be a mixed output or it can be a sorted output as well. Okay, order of execution is dependent on thread scheduler. We will see what is thread scheduler. Then, since the jobs are independent, all that matters is that they get complete as fast as possible. Order of execution does not matter. Fine. Now I will show you the code by implementing the code and running the code. Why I am saying that order of execution will be different. Okay, let's now run the code in our IDE. So this is the code that I have just shown you, the same code, but what I did is I've increased the job. Now it has to print 1000 times, or sorry, 10,000 times, and it has to print the child thread just 1000 times. Why I did this? Because our computer works in milliseconds and nanoseconds, correct? So what I have to do, I have to show you the difference. If I just write 5, it will just print main thread and it will then print the child thread. Okay, we will not be able to see the difference much. Now let's just do this. Just let me run it, and when I run it, you will see that what I have done, I have also printed I, so it will print how many times main printed, then how many times child printed. Let's see. So first child thread is executed. First child thread is executed. It is dependent on what our thread scheduler, which thread is executed. So child thread runs, and child thread runs for 782 times, and after that main thread is executed once. Then after that child thread is executed again. So the order of execution does not depend on us, it depends on thread scheduler. Okay, and then it is running. So for so many times, and in middle, as you have seen, I think yes, these are the child threads. Okay, here till 8:23, and then again the main thread will run, and between you will see child threads coming. So it is executing simultaneously. It is actually executing one by one, but it seems that it is executing simultaneously. Okay, the speed of the execution increase, and at the end main thread is completed. Fine. So this is why I was saying that the speed of the execution matters, but the output does not matter. In multi-threading. Okay, we are not writing a code that output should match. We want our program to be executed as fast as possible. It should seem that both the different tasks are executing at the same time. Okay, it should seem, and it is like that when we use multi-threading. Okay, now I am printing it, therefore you can see the difference, that at this instance of time child thread is running, at this instance of time main thread is running, but it is in milliseconds. We cannot detect it if we do not write this type of code. We cannot detect it. Okay, for us it will be working simultaneously. For example, that right now this id is also running and this ppt is also running, but for us it is running at the same time, but for computer it is scheduling these jobs one by one. Correct. Similarly it is happening here, child thread and main thread. So this was how we define a thread by extending a thread class. So next we will see more information about the start method, the run method. Okay, we will see much more information about these two topics, these two methods, what is a start method and what is a run method. Okay, then we will move to thread states, that is the life cycle of a thread. Okay, so in the next video we will see that. Thank you.